In this video, I will discuss about role of fluids in metamorphism. Before discussing this topic, I will first discuss about the outline. We have discussed metamorphic zones and isogrades in previous videos. Let's now study role of fluids in metamorphism. In this video, I will explain metamorphism and metasomatism in brief. Next, I will discuss classification of metasomatic processes. Further, I will discuss the role of interstitial rock moisture and fluids of foreign derivation in the foregoing slides. Finally, I will summarize my lecture. Here is the introduction of this video. Process of mineral or rock alteration by solutions is called metasomatism. However, it is not confined to metamorphic rocks. Lindgren 1925 has proposed a definition which is as follows: simultaneous molecular process of solution and deposition by which one mineral is changed into another of different chemical composition in presence of fluid phase is called metasomatism. I have already discussed about metamorphism in another video lecture. Let us recapitulate. Metamorphism is the process that brings about changes in the mineralogical and structural and or chemical constituents in a rock, dominantly in solid state. Metamorphism is regarded as a thermal phenomena in which heat is the most important source of energy, causing mineralogical and textural reconstruction. Metamorphism at highest grades coexist with partial melting and may involve changes in bulk chemical composition of the rock. What is the difference between or distinction between metasomatism and metamorphism? Metasomatism occurs in open spaces, in liquids and colloidal media, whereas metamorphism occurs in a capillary spaces. Metasomatism, that's the reactions run by laws of mass action and phase rule, occurs with change in volume but in solid medium, replacement in molecule by molecule, but particle by particle and volume by volume is taking place. Whereas in metamorphism is a complex reactions. They are complex reactions run by surface energy phenomena without change in volume. Original textures and structures remain preserved. Finally, metasomatism is a process of alteration involving enrichment of rock by new substances brought from outside. Enrichment takes place by chemical reactions between original minerals and enriching substances. The chemical reactions leading to metamorphism involve volatiles. Appearance or disappearance of phases makes such reactions largely of net transfer type. The chemical reactions leading to metamorphism involve volatiles. Further appearance or disappearance of phases makes such reactions largely of net transfer type. The contact metamorphism revealed by endogenic and exogenic effects on rocks invaded by igneous mass. Endogenic effects, they are textural and mineral changes in border zone, whereas exogenic effects, they include more distinct, such as baking of nearby rocks and their alteration, old minerals broken up and their ions recombined to form new minerals stable under new conditions. For example, calcium and magnesium carbonates and clay from wollastonite, dolomite, and effects on surrounding rocks are of two types. A. Heat effect alone without accession causes contact metamorphism, whereas B. Heat effect combined with accessions derived from magma causes contact metasomatism. In this diagram, copper skarn deposit shows relationship between contact metamorphic zones, ore bodies and igneous intrusion. You may find the outermost you have a wollastonite zone. The wollastonite zone is within the carbonate rocks. What are the carbonate rocks? Mainly marble and limestone. You may find one central body which is red colored, which is the main source of heat, and surrounding that you may find zones which are shown with yellow color or yellowish brown color. They are basically thermal areole and garnet pyroxene zones. In this diagram also I am showing the shear zone. Along this shear zone you may find lot of wollastonite formation. Now contact metamorphic areole. In this diagram I am trying to show a metamorphic areole here with this diagram. Changes around intrusive body takes place. Shape and size of areole varies and depends on intrusive and characters of invaded rock. Here you have a central magma which has shown in a orange color, and surrounding this magmatic body you have a yellow colored zone of contact which is in contact with marble rocks, limestone and marble, and they get baking effect. They show lot of baking effects in the carbonate rocks. Contact metamorphism and metasomatism. After last stage of magmatic crystallization, high temperature fluid emanations escape into nearby rocks, cause marked effects. Here in this diagram I am showing the porphyry copper deposit showing alteration zoning, associated skarn, replacement and vein deposits. All kinds of these features are formed by a magmatic body which is also forming a porphyry copper type of deposit which is of economic value. And you have a potassic late phylitic overprint, chalcopyrite, pyrite, molybdenite, alteration taking place as prophylitic. Mineralization is mostly in the form of sulfides, and you have a copper ore in the yellow color shown here, and polymetallic deposits, they are mostly in the carbonate rocks, and pyrite deposits are also in the carbonate rocks. You also see the brecciated pipe in the left hand side, which is vertical pipe. Now what is the difference between contact metamorphism and metasomatism? Contact metamorphism differs from contact metamorphism in the manner in which accessions play significant role. Magmatic emanations are highly charged with metal ions and form contact metasomatic deposits, mainly in calcareous rocks. Such deposits are called contact metasomatic deposits. High temperature of deep-seated magma upon invaded rocks, the carbonate rocks are more susceptible, may change to form complex silicate rocks called tektite or skarn, which I have shown in my previous diagrams. Now classification of metasomatic processes. Based on kind of effects on rocks produced by metasomatic processes, we can classify them as silicate rocks, replacement and alteration both taking place. Second is carbonate rocks, where alteration of limestone to dolomite is taking place. Third is salt deposits. Fourth is sulfide rocks. Enrichment reactions lead to sulfide ore deposits. In metamorphism, the main concern is with metasomatic reactions in number 1, silicate, and number 2, carbonate rocks. Metasomatism in silicate rocks is further classified on the basis of nature of additives, either they are metallic or non-metallic compounds. First I will take up the alkali metasomatism, where alkali-rich solutions lead to albitization, analcitization and felspethization of cyst, that is injection metasomatism, and formation of biotite, muscovite and azerine take place. Second, out of this alkali metasomatism, first is magnesium metasomatism. Mg-rich solutions lead to dolomitization of limestone and formation of anthophyllite and cordierite within an areole, giving rise to cordierite anthophyllite cyst. Second is lime metasomatism, where formation of epidote at the expense of mica is taking place. And third one is iron metasomatism. It occurs by several processes through basic rocks, slates and limestone replaced by ferriferous solutions forming iron ores. Addition of non-metals and their compounds including halogens such as chlorine, fluorine, these are the two halogens, and sulfur, phosphorus, water and CO2 is taking place in this kind of metasomatism. The halogen metasomatism, in case of halogen metasomatism, addition of chlorine and fluorine with boron is taking place, and this kind of metasomatism is known as nematolytic metasomatism. First, I will take up about the sulfur metasomatism. It leads to pyritization, formation of pyrite, alunite. Phosphorus metasomatism, that takes place causing replacement of rocks by phosphorus, and mostly apatite is formed in this case. Silica metasomatism, replacement of rocks by chert, opal and chalcedony. Water and CO2 metasomatism, formation of serpentine from olivine, chlorite and biotite, pyroxene and carbonates from calcic plagioclase or calcic feldspar. Then comes the metasomatic replacement. First, the capillary action and deposition occur at once. New mineral form by replacing past minerals. Solutions carry replacing minerals, replaced minerals carried away in solution. Resultant rock with same volume and structure. Form, structure, texture preserved in this case, and mostly pseudomorphs are formed. The pyrite pseudomorph mostly formed in this case. Molecular or atomic size replacement, volume for volume, but no molecule to molecule interchange is taking place. Here is the diagram where I am showing you the mineral deposit showing relationship of ore and alteration zoning in porphyrite intrusion. Here in this case, you may find green color alteration zone where argillitic or propylitic rocks are there. Mineralization is taking place in the form of a base metal sulfide, rhodochrosite, fluorite veins shown with yellow color, and you have a quartz sericite potassic pervasive silicate rock, molybdenite ore shell with fluorite and huberite. Then you find a grisening effect. The rock which is formed by grisening effect is called grazen. You have in this diagram, the grazen veins are there, and intrusive porphyry complex is shown with the help of red color here. Now another diagram I am showing where you can map the alteration zoning, porphyritic zoning, sericite, pyrite, quad tourmaline, metal zoning, lead, zinc, stibnite and tin, tungsten, all zones can be marked by mapping the area. You can also make the cross section. In this case of cross section of individual vein, around this vein you may find a granite contact, upper level and middle level and lower levels. Lower level you find K feldspar, whereas at the top you may find wolframite and other economic minerals. This red colored intrusive body is invading through the metasedimentary country rock. The invaded rock is mostly granite. The types of alteration which is taking place in this case is 5 types of alteration is taking place. Dolomitization, Mg substituting for calcium in carbonates, silicification, adding of SiO2, argillic alteration, formation of clay minerals, porphyritic alteration, where hydrogen ion replaces other cations, characterized by chlorite, epidote, zoisite, calcite, sericite. And E is the sericitization. In this case, fine-grained white mica or sericite is forming in this case. Pneumatolytic metamorphism defined pneumatolysis means gas action is taking place as alteration of rocks due to combined effects of heat and magmatic emanations, mainly consisting of halogens, water, boron compounds, phosphorus, and alkali metals. Mineral forms mostly muscovite, lithium mica, fluorite, topaz, tourmaline, axinite, apatite, scapolite, and beryl. The alteration type which is taking place in this case, both endogenous of igneous body and exogenous of nearby rocks, is taking place in case of pneumatolytic metamorphism. Types of pneumatolysis. Number 1, first type is tourmalinization, combined effect of H2O, that is water vapor, boron and fluorine forms tourmaline granite. Greasening, action of superheated stream and fluorine forms greason with white mica, often lithium bearing mica, and topaz is formed. Kaolinization, mostly due to superheated stream aided by little fluorine and bromine, forms mostly kaolin. Kaolin is a clay mineral. Injection metamorphism and autometamorphism. Injection metamorphism due to injection into rocks leads to alkali metamorphism, mainly causing felspethization. Autometamorphism, alteration of rocks by its own residual fluids, for example, albitisation. Third one is analcitization, is similar to albitisation, but lime soda feldspar are partially replaced by analcite. Then another important process by which a lip-parlit gneisses or migmatites and anataxis is taking place. Lip-par injection of granitic magma along foliation planes of country rock, forming banded or lip-parlit gneisses where alternate bands are altered by transfused magmatic emanations, is called lip-parlit injection. Mostly the migmatites are formed. What are the migmatites? Migmatites are assimilation of country rock at great depths with interchange of its material with magma produces admixture of pasty mass with gneiss structure is called migmatite. Then the process is anataxis. What is anataxis? It is the process of granitization on regional scale with production of pasty mass retaining a few magmatic characters is called anataxis. Another process which is taking place is called palingenesis. Complete mixing and melting of rocks with the formation of new magmatic body capable of injection and passing through a cycle of igneous change. This process of regeneration of magma is called palingenesis. This definition is given by Schiederholm in 1923. Now, viewers, let us summarize what we have discussed in this video. Fluids produce contact somatism and contact metamorphism. Contact metamorphism describes how direct contact with hot magma can change the texture and mineralogy of rocks, mostly through heat transfer. Whereas contact metasomatism is a particular kind of contact metamorphism in which rock's composition also undergoes significant changes, mostly as a result of interaction with chemically active fluids released by magma, which introduces new elements into the rocks. Contact metasomatism differs from contact metamorphism in the manner in which accessions play a significant role. Here, areoles show endogenic and exogenic effects. Both types of effects can be seen here. In case of alkali metasomatism, that is Mg metasomatism, iron lime rich solutions and non-metals such as chlorine, fluorine, boron, water vapors, that is steam, and carbon dioxide produce metasomatism. Contact metamorphism produces areole, which is also known as skarn or skarn deposit. Former causes dolomitization, silicification, sericitization, and porphyritic and argillitic alterations. Pneumatolysis is liable to tourmalinization, greasening, and kaolinization. Intensity rise produces injection metamorphism, autometamorphism, palingenesis, lip parlite injections, and anastasis. Migmatites also form by such processes. Thank you, viewers.